A very good afternoon to all of you, my dear students. A very warm welcome to all of you to the very important and the very best study channel, that is Perry's Study and Motivation. Okay, so this is your Lalita Perry ma'am, your chemistry teacher. Okay, I basically work for Perry's Study and Motivation channel. Okay, so if you are very new to my channel, please kindly visit my channel and watch the videos which I have uploaded already for the students of classes 9th to 12th. Okay, so once again I am very much thankful to all of you that you are visiting my channel, and most of the students are giving better comments also. Okay, so once again a warm welcome to all of you to the very important study channel, that is Perry's Study and Motivation. Okay, so today in today's video we are going to learn about what? We are going to learn about the topic, the very first topic of class 10, that is chemical reactions and equations. Okay, so without any delay, let us go into the topic. Okay, so today we are going to discuss about what? Chemical reactions and equations. Okay, now chemical reactions and equations. This is our topic for today. Okay, so this is the chapter in which we are going to discuss about certain types of chemical reactions. Okay, and different examples which are being to be read under different types of chemical reactions. Okay, and how to write a balanced equation for a given chemical reaction. Okay, and how many types will be there. Okay, different types of chemical reactions which are occurring in our daily life, all these we are going to discuss. Okay, so generally these videos, these chapters are uploaded, are going to be uploaded like in different parts. Okay, so first we will deal with conceptual overview, and then we'll come to objective part also. Okay, so once again I request all of you, those who are watching my videos for the first time, kindly visit my channel and please don't forget to subscribe to my channel. Okay, and at the same time share my videos to most of your friends so that I will be very much helpful to all of you, and I'll do my best to give the best content for all of you. Okay, so let us go into the topic, chemical reactions and equations. You know that if you are dealing with a reaction, actually if you are dealing with a change, okay, you have two types of changes are there, physical and chemical changes. Okay, so physical changes are the type of changes which are going to occur temporarily, and chemical changes are the changes which are going to occur permanently. Okay, and new products are going to form in chemical reactions or chemical changes. So what is a chemical reaction? Okay, chemical reaction means what? If two or more substances combine with each other to form a new substance, then you call it as a chemical reaction. Okay, suppose A plus B gives rise to C plus D. Okay, here the substances which are participating in the reaction, you call them as what? Reactants, and the substances which are newly formed are called as what? Products. Okay, so like that, reactants gives rise to products. Okay, this arrow you have to read it as what? Gives rise to. Reactants gives rise to products. Okay, so such kind of chemical changes where if two or more substances are combined together, and if they are going to give you a new substance, entirely new substance if it is going to form, then you call such substances, you call such chemical changes as what? Chemical reactions. And all the chemical reactions are represented symbolically. Okay, and that only you call it as what? Chemical equation. Okay, so what is a chemical equation? Chemical equation is a symbolic representation of a chemical change. Okay, now symbolic representation of a chemical change is called as chemical equation. Okay, so this is all the basic concept which you already have learnt in your lower classes, right? So we'll go for the types of chemical reactions. What are the different types of chemical reactions? Okay, basically we have 4 types of chemical reactions are there. Okay, so what are the different types of chemical reactions? We are going to discuss about this. In this video, we will be discussing about some types, and in the next coming video, the remaining types we will discuss. Okay, and altogether objective part we will discuss in one more video. Like that, one lesson we will be dividing into 3 equal parts, and we will discuss the concept in the first and second videos, and in the third video what kind of questioning you will be getting in your competitive exams. Okay, so that we will discuss, so that you will have an idea of how what kind of questions you have to face during the competitive exams. Okay, so concept is also very much important, dear children. So without skipping the video, I request all the students to watch the video till the end. Okay. So types of chemical reactions. Once you look at this, we have basically 4 types are there. What are the different types of chemical reactions? Basically 4 types are there. So first one is what? Chemical combination reactions. Okay, now chemical combination reactions. Second type are what? Chemical decomposition reactions. Chemical decomposition reactions. Third type are what? Chemical displacement reactions. Displacement reactions. And you have fourth type are what? Chemical double displacement reactions or double decomposition reactions. Basically, you have these 4 types of reactions. Okay, now 4 types of chemical reactions are there. And in addition to this, you have redox reactions are also there. Redox reactions. And you also come across the reactions which we will come across in our daily life. What are those? Yes, corrosion reactions. Corrosion, okay, which will be seen in our daily life. Okay, so corrosion reactions. Like this, we have to discuss about all these types of reactions and with certain examples also. Okay, so in this video, we'll try to discuss only some up to displacement reactions we'll try to discuss. Okay, and then the remaining reactions we'll be discussing the next coming video. Okay, so let us go for the first type of reactions. What are those? Chemical combination reactions. In the name itself it is there. What are combination reactions? The type of reactions in which reactants can be many but product is only one. Reactants can be 2 or more. Okay, now many, but product is only single product. Then you call them as what? Such reactions are called as chemical combination reactions. Okay, now many reactants, 2 or more substances may combine with each other, but if the product formed is a single substance, then you call such reactions as what? Combination reactions. Okay, like for examples, if you go for different examples, okay, examples are very much important. You have to identify the type of reaction, whether it comes under combination or decomposition or displacement or double decomposition. Identification is very much important for you. Okay, so single product combination reactions means what? Reactants can be 2 or more, but the product formed is compulsorily a single product. Here carbon is a solid substance. Whatever the physical states of the substances, we are going to indicate them down in the bracket. Okay, C is a carbon. Carbon is a solid substance. I wrote that in the form of what? A bracket. Inside the bracket, solid S. And oxygen is a gas, so it is G. And even the product carbon dioxide, CO2 means what? Carbon dioxide. It is also a gas. If the gas is going to get liberated, okay, in the product side, we are going to indicate that with an upward arrow. So C plus O2 gives rise to CO2. Here reactants are 2, product is 1 only. Okay, S plus O2 gives rise to SO2. Okay, here what is S? S is sulfur powder. Okay, sulfur powder. Sulfur powder, when it is burnt, okay, it gives rise to a colorless gas, that is sulfur dioxide. Okay, and remember that sulfur powder is pale yellow in color. Okay, please remember that the color of sulfur powder color is what? Pale yellow color. It is like Complan Kesar Badam color. I think you all have idea. Okay, Complan Kesar Badam, how does it look like? Yes, it is pale yellow colored powder. Okay, sulfur powder is a pale yellow colored powder. When you are burning that sulfur powder, okay, now if you are taking a deflagrating spoon and burning that on a flame or keeping it on a flame, then sulfur catches fire and it burns with what? Blue colored flame. Okay, now please remember this kind of points also. Okay, now not only the reactions, with what color, what is the color of that particular substance, and with what flame you are going to get the color of the flame. Okay, and sometimes what is the substance which is newly formed, that may be colored. You have to remember the color changes. You have to remember the names of the substances as well as their molecular formulas also. Okay, so you have to be very conscious when you are listening. That's why I request all the children to please make notes and practice. Then it will become very much useful for you. Okay, so S plus O2 gives rise to SO2. Sulfur burns with blue flame and forms a colorless gas, sulfur dioxide. Even carbon dioxide is also a colorless gas. Okay, now colorless gas, sulfur dioxide. Okay, so this comes under what? A combination reaction. Okay, so when we are learning about certain reactions, we will be learning about certain characteristics that are being possessed by that particular substances also. Okay, just learning the examples is not enough. Okay, you have to learn the characteristic properties that are being exhibited by that particular substance. Here I told you the example of sulfur powder. Sulfur powder is pale yellow colored and giving, on heating, it is giving what? Colorless sulfur dioxide. Okay, now remember, write it as a note point. Sulfur dioxide acts as a very good bleaching agent. Okay, now sulfur dioxide acts as bleaching agent, a very good bleaching agent, or you can even term it as, you can even call it as dehydrating agent. Okay, now dehydrating agent. So what does it mean? Dehydrating agent or bleaching agent means what? Okay, if any vegetable coloring matter is exposed to sulfur dioxide, okay, that vegetable coloring matter becomes colorless. What I meant to say is, if you are exposing this sulfur dioxide gas to any colored flowers like rose flower, red rose, okay, petals of red rose, if they are exposed to the sulfur dioxide gas, okay, then if you observe for a few seconds, okay, then the color of that rose petals, red rose petals, will turns white or they turns colorless. That means what? It absorbs this sulfur dioxide acting as a bleaching agent. It bleaches out the coloring matter which is there in that rose petals. Okay, now pigments all gets what we can say, they can be absorbed. Okay, now all the pigments, coloring pigments whichever are there in the rose petal, they get absorbed. Okay, that means it is acting as what? Bleaching agent. It bleaches out the coloring matter which is there in fruits as well as vegetables as well as flowers also. If you take carrot, carrot is a colored vegetable. Okay, orange colored vegetable. If you cut small pieces of carrot and expose them to sulfur dioxide gas, the color of carrot pieces will get faded away. Okay, which says that sulfur dioxide acts as what? A very good bleaching agent. Okay, or dehydrating agent, anything you can say. What is dehydrating agent? Which removes water molecule. Okay, now water molecule, if it is being removed from any substance, you call that substance, you call it as what? Dehydrating agent, to remove the water molecule. Substance which removes water molecule from another substance, okay, you call it as what? Dehydrating agent. Okay, so this kind of other things which we are giving you, other informations which we are giving you, those are also very much important, dear children. That's why concept is also very much important. Okay, so let us go for the third example. Example 3. 2 Mg plus O2 gives rise to what? 2 MgO. This is also an example for what? Chemical combination reaction. Okay now, see here, Mg stands for what? Magnesium ripple. Okay now, Mg will be available to you in the form of magnesium ribbon. Okay, and magnesium ribbon, when you are burning that in presence of oxygen, here reaction with oxygen means what? Nothing but combustion reaction, or in other words it is what we call oxidation reaction, or in other words you can call it as a burning reaction. Burning is possible only with the help of what? Oxygen, isn't it? So 2 Mg plus O2 gives rise to what? 2 MgO. Here magnesium ribbon, it burns with dazzling white light. Please remember, burns with dazzling white light means very bright intense light will come. If you are burning a magnesium ribbon, it burns with dazzling white light. Okay now, it burns with dazzling white light and forms magnesium oxide, which is considered to be like a white colored ash. Okay now, white ash like that it will form. Okay, suppose if you collect that magnesium oxide in a china dish. Okay now, magnesium oxide, if you are collecting that in a china dish and you are adding water to that, then it gives rise to another new substance which is called as what? Magnesium hydroxide, MgOH taken twice. Okay now, magnesium hydroxide. Okay, so here you have to do the balancing for this reaction. Okay, so here magnesium oxide gives rise to magnesium hydroxide. This magnesium hydroxide will be basic in nature. Okay, I think you have idea about acids and bases. Here metallic oxides, magnesium is a metal, its oxide is what? Magnesium oxide. Okay, and its respective hydroxide is what? Magnesium hydroxide. It is what? Basic in nature. Please remember, it is basic in nature. Okay, that means what? It turns the indicator substance phenolphthalein is an indicator substance, synthetic indicator, which is used to indicate what? Whether the given substance is acidic or basic or neutral also. Okay, suppose if you are adding phenolphthalein to this basic substance. Okay now, phenolphthalein, if it is added, then that basic substance turns to what? Pink color. If you observe the formation of pink color, okay now, formation of pink coloration, if you can observe, then that indicates what? That particular substance exhibits basic character, means it's a base. Magnesium hydroxide is a base. And you have to remember one more point regarding this magnesium hydroxide. Magnesium hydroxide also called as what? Milk of magnesia, and it acts as a very good antacid. MgOH taken twice is called as what? Milk of magnesia. Milk of magnesia, and this will be acting as a very good antacid. Okay now, antacid, which means what? To reduce the burning sensation which is caused due to acidity in our stomach. Okay, so antacid, milk of magnesia. Okay, so magnesium hydroxide is basic in nature. It is a mild base and which is used for us in the form of what? Antacid. Okay, so this reaction MgO plus H2O gives rise to MgOH taken twice. This reaction is also a combination reaction only. Here also reactants are 2, product is 1 only. Okay, so let us move on to the fourth example. Okay, calcium oxide when reacts with water, okay, it gives rise to calcium hydroxide. Okay, calcium oxide is generally called as what? Quicklime. Okay now, calcium oxide is called as quicklime, and calcium hydroxide is called as what? Slaked lime. Okay, quicklime and slaked lime. When added with water, you will find a small very low hissing sound you will be getting. Hissing sound. Okay now, when water is being added to calcium oxide, okay, you will observe. What observations you will make here? You will find a hissing sound. Okay, hissing sound is coming. Okay, which indicates that with the hissing sound, you can even observe the container becomes hot also. Okay, the container in which calcium oxide and water are taken, the container becomes hot. Okay, so which indicates that the reaction is exothermic reaction, Means what? What is exothermic reaction? The reaction in which heat energy is released is called as exothermic reaction. Please remember, this is also a combination reaction only. Reactants are 2 and product is 1 only. But here you are indicating with another new name. What is that? Exothermic reaction. Which means what? Reaction in which heat energy is released. The reactions in which heat is released. Reactions which are associated with release of heat energy are called as exothermic reactions. Okay, now heat energy is released. Then you call them as what? Exothermic reactions. So here mixing of water to calcium oxide to form calcium hydroxide, it's an exothermic reaction. Okay, that means the test tube or the container in which the reaction has been taken place, that will become hot. Okay, which indicates that it's an exothermic reaction. Okay, and same like that, if you are passing carbon dioxide gas to calcium hydroxide, and you know this is the principle in which whitewashing of walls takes place. See here, quick lime when added to water, you got slaked lime. Okay, slaked lime is what? Calcium hydroxide. This calcium hydroxide, when it is being painted on the walls, okay, now for wall painting we will use it. Okay, when it is being painted and after it gets dried, it appears more shiny. Okay, this will become more white and bright, shiny it will appear after it gets dried. That means what? When it is in wet condition, it absorbs the atmospheric carbon dioxide. Okay, now it absorbs atmospheric carbon dioxide and forms a white precipitate, CaCO3. Okay, and along with that water also will form. Okay, so CaO plus CO2 gives rise to CaCO3. Okay, it's a white precipitate which is formed on the walls of the building. Okay, that's why after getting whitewashed, walls appear to be more shiny and bright. Okay, so because of the formation of this white precipitate. Okay, but this is not the example for what we call combination reaction, because here reactants are 2, products are also 2. Okay, but product should be 1. In case of combination reactions, product should be what? Only 1. But here why I am telling this example means you will be given question as an integrated question. Means, okay, it's not like you are limited to only one type of reactions, not like that. The question can be asked from any corner also. Okay, so you have to be very careful and concentrate on the whole topic. Okay, so this question can be asked in the form of XYZ question. A substance X, when made to react with gas Y, okay, the gas Y, which is used as a fire extinguisher. The gas Y is being used as what? As a fire extinguisher to give a white precipitate of CaCO3. Identify X and Y and write the relevant chemical equation. Like that you will be getting questions. Okay, then you have to identify this X and Y. Okay, and same like that you have regarding this equation, you have another equation is also there, CaCO3 plus H2O. If you are passing excess CO2 to this, excess carbon dioxide, if it is passed through this solution, then this white precipitate gets dissolved. Please remember that point very carefully. This white precipitate gets dissolved because of the formation of CaHCO3. Okay, now CaHCO3 means calcium bicarbonate. Okay, this will form a what? Clear solution. This forms a clear solution. That means white precipitate which is formed over here, that gets disappeared. Okay, it gets dissolved, and you will be getting again what? A clear solution. Okay, so like that also you will be getting certain questions. They'll ask you to write relevant equation. They'll ask you to identify what is the substance formed over here. Okay, so you have to be very careful with this. Okay, so these are the different examples for what? Combination reactions. Of course, these two are not combination reactions. Okay, but I just told you here to remember the concept. The way of questioning may be asked like XYZ. That's why you have to understand this way of questioning also. That's why I gave these two examples. Let us go for the fifth example, which is there for us. N2 plus 3H2 gives rise to 2NH3. This is formation of ammonia. NH3 means what? Ammonia. Nitrogen reacts with hydrogen to form ammonia. Okay, so here also reactants are 2, product is 1 only. So it comes under what? Combination reactions. Like that you have lot many examples are there for combination reactions, chemical combination reactions. Okay, so you have formation of metal oxides, okay, formation of metal sulfides, okay, all those also comes under chemical combination reactions only. Okay, like you can take not only the formation of gases, okay, like I told you S plus O2 gives rise to SO2, same like that N2 plus O2 gives rise to 2NO. This is also a combination reaction. P4 plus 5O2 gives rise to 2P2O5. Okay, P4 means what? Phosphorus. Phosphorus is a tetraatomic element. Okay, reacts with 5 moles of oxygen to give 2 moles of P2O5. What is P2O5? P2O5 is a phosphorus pentoxide. Okay, now phosphorus pentoxide. Now, okay, it appears to us like a flashlight in graveyards. Flashlight. Phosphorus is highly reactive non-metal. Please remember, phosphorus is what? Highly reactive non-metal. Okay, when reacts with atmospheric oxygen, okay, 5O2 here this is atmospheric oxygen. If phosphorus is reacting with atmospheric oxygen, immediately it forms like a flashlight, a spark like a spark. You will observe P2O5. Formation of P2O5 is observed in the form of a light little spark. Okay, phosphorus pentoxide will form. Okay, so this is also an example for what? Combination reaction only. Okay, same like that Cu plus Cl2 gives rise to CuCl2. Okay, copper chloride. Okay, copper chloride is blue in color. This is also an example for combination reaction only. Okay, so same like that you have lot many examples are there. Okay, for combination reactions, in all these reactions what you have observed, reactants can be many but product is only one. Such kind of reactions are called as what? Chemical combination reactions. Now slowly we'll move on to the second type of reactions, that are chemical decomposition reactions. So what are chemical decomposition reactions? Chemical decomposition reactions. Okay, here you will be finding decomposition reactions. In the word itself it is there. Okay, synthesis and analysis. You will use the words synthesis for combination reactions and analysis for decomposition reactions. Means here decomposition means what? Splitting of single substance into 2 or more. Okay, now splitting of single substance into 2 or more substances. Splitting of single substance into 2 or more substances. Then you call it as what? Decomposition reactions. Okay, like these decomposition reactions are again classified into 3 types. Okay, first type are what? Thermal decomposition reactions. Thermal decomposition. Second type are what? Photochemical decomposition reactions. Okay, now photochemical decomposition reactions. And third type are what? Electrolysis. Okay, now electrolysis is also a decomposition reaction. Okay, so here let us learn examples for these types of decomposition reactions. What are the different examples? Okay, so first if you go for thermal decomposition, in the name itself it is there, thermal. The word thermal stands for what? Thermal decomposition. Here the word thermal stands for what? Yes, heat energy. Okay, heat energy. If you are supplying some heat energy, then the single substance splits into two or more. Like you can take the example of calcium carbonate. On heating, you are going to represent like this. On heating, it gives rise to CaO plus CO2. That means single substance on heating splits into two substances. Okay, on heating, thermal decomposition it is. That means when you are heating that particular substance splits into two or more. Okay, so calcium carbonate is what? CaCO3. CaO is quicklime, carbon dioxide escapes out. Okay, same like that you can take potassium chlorate, 2KClO3. On heating, it gives rise to 2KCl plus 3O2. This is also thermal decomposition reaction only. Here one point you have to remember. This reaction requires 320 degrees centigrade of temperature. Okay, suppose if you take manganese dioxide as catalyst, this is very important, keep star for this reaction. Manganese dioxide, if you use it as a catalyst, MnO2 if it is used as a catalyst, and if you are heating that substance, then the reaction can be completed at 240 degrees centigrade only. Okay, now that means the reaction is happening quickly in presence of a substance, and that substance you call it as what? Catalyst. Catalyst is a substance which increases the rate of a reaction. Okay, which speeds up the rate of a reaction. Catalyst. Okay, which promotes the rate of a reaction without itself undergoing any chemical change. It itself does not participate in the chemical reaction, but it speeds up the rate of a reaction. So here in this reaction, the catalyst used is what? Manganese dioxide is used as catalyst. Okay, so such kind of questions also you will be coming across. So you please go through that. Okay, and next we will go for some other examples. Once again, thermal decomposition reactions. Okay, as usual, CaOH taken twice on heating, it splits into CaO and H2O. Okay, now CaOH taken twice is what? Calcium hydroxide, as I already have written, CaOH taken twice on heating, it can split into calcium oxide and water. Okay, on heating. So like this you have single substance on heating splits into two or more substances. And here sometimes they may ask you about the gases released. Here you are finding the gas released is oxygen. Here you are finding the gas released is carbon dioxide. Okay, so what are the tests for carbon dioxide and test for oxygen? Sometimes you will be getting questions even like this also. What is the test for carbon dioxide? I mean, how can you say that the gas released is carbon dioxide only? Okay, so you know that carbon dioxide turns lime water milky. Turns lime water milky. Okay, so this is the test for carbon dioxide gas. And oxygen, what is the test for oxygen gas? Oxygen gas burns the, means if you keep a burning splinter, okay, it burns more brightly. Okay, a burning splinter burns more brightly. If a burning splinter burns more brightly, then you can say that the gas released is oxygen only, more brightly. Okay, burning splinter means nothing but a glowing matchstick or a glowing agarbatti you can take. Okay, it burns, if it burns more brightly, you know that oxygen is a very good supporter of what? Combustion. Oxygen, okay, is a good supporter of combustion reactions. Okay, even we have this type of combustion reactions are also there. We will be learning about that also, right? So carbon dioxide, oxygen tests also sometimes you will be asked to write. So remember the tests also. Okay, so this is about what? Thermal decomposition reactions. And then we have to go for what? Photochemical reactions. Photolytic decomposition. Okay, second type is what? Photolytic decomposition. Here that means the decomposition which happens in presence of sunlight. Here photons means what? particles of light are called as what? Photons. Please remember, photons means particles of light. Okay, so here if the reaction is happening in presence of sunlight, then such kind of reactions are called as what? Photochemical reactions. Okay, here photochemical decomposition should take place. For that you can take the best example is AgBr. It decomposes into metallic silver and bromine gets escaped out. Okay, 2AgBr gives rise to 2Ag plus Br2. Okay, AgBr will be yellow in color. Please remember the colors also. Silver bromide. AgBr means what? Silver bromide. AgBr will be yellow in color and you will be getting metallic silver here, grey. Okay, so yellow colored AgBr turns to greyish black metallic silver. Okay, in presence of what? Sunlight. Okay, the reaction is happening in presence of sunlight. Then only you call it as what? Photochemical reactions. Okay, and even you know photosynthesis is also a photochemical reaction. It is not photolytic reaction. Please understand the difference carefully. If any substance is breaking, then that comes under decomposition. Okay, now if any substance is breaking or splitting into two parts, it comes under decomposition. But here what I was telling you, photosynthesis is not photolytic reaction, it is analysis, it is synthesis reaction. Photosynthesis is an example for photochemical reaction but not photolysis. The word lysis stands for what? Breaking. Please remember, the word lysis stands for breaking. It's a photochemical reaction. Photosynthesis is photochemical reaction, but it's not photolysis. It's not photolysis reaction. Please remember, it's not photolysis. Lysis means the word lysis or lysis stands for what? Breaking. Okay, if breaking of a molecule into its ions or into smaller compounds takes place in presence of sunlight, you call it as photolysis or photolytic decomposition you call. This is the best example for photolytic reaction. Okay, so AgBr, even AgCl also, when it is kept under sunlight, it gives us metallic grey, grey colored silver, and chlorine gas escapes out in such cases. Okay, so these all comes under what? Photolytic decomposition reactions. And third category are what? Electrolysis reactions. Electrolysis is also a kind of decomposition reaction only. Electrolysis. Okay, decomposition of a substance into its ions by the passage of electricity through it. Okay, now decomposition of a substance into its ions by the passage of electricity through it. Such kind of reactions are called as what? Electrolysis reaction. Lysis, here also the word lysis is there. The word lysis stands for what? Yes, the word lysis stands for breaking. Okay, now breaking. Okay, so electrolysis means you require, there is a process is there for this. Okay, you require a beaker, okay, in which you are going to take a liquid substance, okay, liquid substance which can able to conduct electricity, and that liquid substance you call it as what? With the name electrolyte. Okay, the liquid substance can be an electrolyte, and you are going to take two metal plates or two rods which are made of either carbon or platinum or any inert substance or even graphite, anything you can take, or you can take certain less reactive metal plates can be taken as in, and they are to be dipped inside it, and you are going to wind a copper wire through these two metal plates and connect the ends of the copper wire to a high voltage battery. Okay, and if you wanted to check whether current is passing or not, you can even keep an electric bulb. Okay, right? So if you are connecting the terminals of the high voltage battery, okay, if you are passing current through it, then what will happen? If it is an electrolyte means what? The substance which can split into ions. Okay, the substance on passing electricity, it can split into ions. So these electrolytes can be either acids, or they can be bases, or they can be salts, salts also, salt solutions, okay, electrolytes. So if you take any acidic substance in the beaker, it splits into its ions, okay. That process you call it as what? Electrolysis. Even basic substances, okay, like we'll take certain examples, okay. Suppose if you take example of acids, okay, HCl will take, dilute HCl. Dilute HCl, if it is taken as an electrolyte, it decomposes into what? H plus and Cl minus ions on passing electricity, okay. So this kind of splitting, and here the bulb, if you take this substance to be the electrolyte, the bulb will glow, okay. So this is an example for acid electrolyte. Basic electrolyte, if you take, you can take the example of NaOH, okay. Now it's a strong base, dilute NaOH solution, okay. Now dilute aqueous NaOH solution, on passing electricity it decomposes into what? Na plus and OH minus ions will be there. Aqueous you have to take, aqueous, okay, aqueous solution of NaOH. If you take, it decomposes into Na plus and OH minus ions, okay. Even if you take any salt substance, okay, now salts, if you take salts like NaCl, aqueous NaCl if you take, okay, salts like NaCl, aqueous NaCl if you take, on electrolysis you get Na plus and Cl minus ions. That means that electrolyte which is taken is getting decomposed into its respective ions, okay, and that process you call it as what? Electrolysis, okay. Here you will be getting certain substances will get migrated towards cathode, one of the metal plates which is connected to the positive terminal, you call it as anode, and the metal plate which is connected to the negative terminal, you call it as cathode, okay. All the positively charged ions will migrate towards cathode, and all the negatively charged ions will get migrated towards anode. So at cathode and at anode certain reactions you will be taking place. At cathode always reduction reaction will takes place, okay. Now reduction at cathode, reduction will takes place. What is reduction? Reduction is gain of electrons will takes place. We'll learn more about these reactions in the next coming video also. Gain of electrons is called as reduction. Always at cathode reduction will takes place, and always at anode oxidation will takes place, okay. In any electrolytic reactions at anode always oxidation takes place. And what is oxidation? Loss of electrons, you call it as oxidation, okay. Exactly, with more number of examples we will be discussing this in the next coming video, of course, okay. So this is all about what? Electrolysis reactions, okay. So electrolyte can be either an acid or a base or a salt substance, okay. So you have to remember those all things, right. And next we'll move on to the third type of reaction, that is displacement reactions. What are displacement reactions? Okay, chemical displacement, in the name itself it is there, chemical displacement reactions. So what are chemical displacement reactions? The reactions in which one substance takes the place of the other substance, okay. Like AB together they are there in the compound, and they are reacting with another substance C. This C is replacing the place of B, and A and C are forming a new compound, and B gets displaced out, okay. B gets separated out. This process you call it as substitution, okay, or chemical displacement reactions, okay. So generally what happens? Highly reactive substances, highly reactive metals displaces less reactive metals from their salt solutions. This is what generally happens in displacement reactions. Highly reactive metals displaces, okay, now highly reactive metals displaces less reactive metals from their salt solutions, okay. Now highly reactive metals displaces less reactive metals from their salt solutions. Okay, this is what you call it as displacement reaction. Okay, like you can take the example of suppose you can take an example like aluminium reacts with iron oxide. Okay, it gives what? Aluminium oxide 2Al plus Fe2O3 4Al we have to take here, 4Al, so that gives you 2Al2O3 plus 2Fe. Okay, so this reaction is called as a displacement reaction. This is an example for what? Displacement reaction. Here aluminium is a highly reactive metal. Okay, highly reactive metal. Okay, it is reacting with a less reactive metal which is there in the salt solution. Okay, according to the definition, what you have to understand, highly reactive metals displaces less reactive metals from their salt solutions. Here aluminium is more reactive than iron. Okay, that's why the place of oxygen and iron has been displaced. Iron got separated out and aluminium and oxygen mix it together to form aluminium oxide. That means displacement is happening here. Okay, then we'll learn one more example here. Just look at one more example. Cu plus FeSO4. Okay, gives rise to CuSO4 plus Fe. CuSO4 plus Fe gives rise to FeSO4 plus Cu. Okay, copper sulfate is actually a blue colored salt. Aqueous copper sulfate solution you are taking, and in that iron nails, Fe in the form of iron nails you are dropping. Okay, then if you observe, after some time this blue colored copper sulfate changes into dull green colored ferrous sulfate, and all the iron nails are getting deposited with red colored copper. Okay, red deposit of copper you can observe on iron nails. Okay, now red deposit of copper on iron nails. Okay, now red copper is getting deposited on iron nails. Okay, so this is an example for what? Displacement reaction. Okay, so here also you have to remember the color changes also. But here one important thing you have to remember, my dear children. How can you say that? Here again I am saying copper is more less reactive, iron is more reactive. Please remember, Cu is less reactive. The metal which is there in the salt should be less reactive. Please remember, displaces less reactive metal from their salt solutions. That is the definition. The metal which is there in the salt should be less reactive metal. Okay, and the metal which is coming individually, okay, for getting reaction, this is coming individually, that metal should be more reactive metal. Okay, okay, so what I said, highly reactive metals only can displace less reactive metals. If you take this reaction to be reverse, like if you take less reactive metal, can it displace the more reactive metal which is there in the salt solution? No, it is not at all possible. Like if I take the reverse reaction, okay, if I take the reverse reaction like Fe plus Al2O3, if I take, can you get back Al2O3, Al and Fe2O3, can you get? Al plus Fe2O3. Is this reaction possible? No, not at all possible, because less reactive metal cannot displace more reactive metal. Okay, now less reactive metal cannot displace more reactive metal. Okay, cannot displace more reactive metal from its salt solution. So reverse reactions are not at all possible. Okay, then how can you say whether a metal is a less reactive metal or it is a more reactive metal? How can you say? how can you say whether a metal which is given to you is less reactive or more reactive than the other? How can you compare? How can you compare the reactivities of metals? For that you have one series which is called as what? Reactivity series. This will be very much useful, dear children. Okay, reactivity series. Okay, so what is that reactivity series? That means series of elements which are arranged in the decreasing order of their reactivities. Okay, the most highly reactive metal is potassium, then sodium, then calcium, magnesium, aluminum. These are what? Highly reactive metals. Please remember. Okay, now these are present on the top of the reactivity series. Potassium, sodium, they can react even with the atmospheric water. Okay, atmospheric oxygen also, and they can burst, they can burn. Okay, even with atmospheric oxygen also, or even with atmospheric water vapor also, they are highly reactive. Okay, so next these all metals comes under highly reactive metals. Okay, and next metals like zinc, iron, lead, okay, and then tin. Okay, these metals comes under moderately reactive metals. Moderately reactive metals. Okay, here zinc, Fe stands for iron, Pb means what? Plumbum or lead, Sn is for tin. Okay, these are moderately reactive metals. And finally you have copper, Cu, Ag, Au, Hg. Hg is for what? Mercury, hydrogen. And finally Pt. These are what? Less reactive metals. Okay, less reactive metals. Okay, so this series of elements which are arranged in this decreasing order of their reactivities, that series you call it as reactivity series. And you have to remember this reactivity series in order to identify whether displacement reaction is possible or not. You can identify. Here you can see copper and iron. Iron is more reactive than copper. Okay, now iron is in the moderately reactive series, copper is in the less reactive series. So iron can displace copper, but copper cannot displace iron. Okay, if you take this reaction, these two as reactants, you cannot get back these two products. Okay, please understand the point carefully. Okay, only highly reactive metals has to be single. Less reactive metals are to be in their salt solutions. Okay, so highly reactive metal only can displace less reactive metal from their salt solutions. Such reactions are called as what? Displacement reactions. Okay, and even you can take the example of like you can take metals when they made to react with acids, then liberation of hydrogen gas is also one of the things. In after this Sn, you can even keep hydrogen also in this. Okay, please keep hydrogen also. Hydrogen, even though it is a non-metal, it is kept in metal reactivity series only. Why it is like that? Because hydrogen, like metals, it also forms cations only. Okay, please understand the point carefully. Okay, you have lot much subject is there to learn, dear children. That's why please focus on all the concepts. That's why I am delivering all the concepts directly here. We have very less time. You have to learn lot many things. That's why, okay, you have to make notes and practice, right? Hydrogen also to be placed under this category only, in the reactivity, moderately reactive category. Okay, suppose if you take the example of metals when react with acids. Okay, any metal when react with acids, sodium metal I am taking, made to react with HCl, then what you will be getting? NaCl plus immediately hydrogen gas is liberated. Okay, this is also displacement reaction only. Here hydrogen got displaced from H and Cl. Sodium is highly reactive, hydrogen is less reactive. That's why hydrogen gas escaped out. Okay, you can even take any metal and any acid. Okay, so here MgSO4 you will get, and hydrogen gets separated out. Okay, suppose if I take gold or silver metal, I am taking silver metal, I am dissolving it in HNO3. Okay, then will I get hydrogen gas? Okay, once just check with the reactivity series, will I get H2 gas? Obviously no. Here no liberation of H2 gas, because here silver is less reactive than hydrogen also. So if a less reactive metal is there, how can it displace hydrogen from that? So no hydrogen, no H2 liberation. For less reactive metals, if they are dropped in acids, less reactive metals like copper, silver, gold, mercury, platinum, all these, if they are dissolved in what we call any acid, even if it is a concentrated acid or a dilute acid, liberation of hydrogen gas generally happens. But if you take less reactive metals and drop them in acids, you will not find the liberation of hydrogen gas. Okay, so no liberation, no H2 liberation. Okay, because silver is very less reactive than hydrogen, so hydrogen cannot be displaced from HNO3. Okay, so like this you will be getting certain important questions. So I request all the children to please kindly pause the video, keep writing, make notes of what all you are writing. Okay, and those who are visiting my channel for the first time, I request all of you not to forget not to subscribe, not to forget to subscribe. Don't forget to subscribe to my channel, dear children. I'll be very much thankful to you if you are going to share my videos to most of your friends, so that the concepts reach them without any delay. Okay, so I request all of you to please kindly make notes and practice. I always say your hard work is your superpower. So happy learning, my dear children. Thanks for watching. Bye.